So we're going to see some distances, and I kind of wanted to put this perspective. 100,000 light years is how wide our Milky Way galaxy is. So galaxies come in clusters. These clusters of galaxies are actually, the galaxies themselves are kind of stuck together with and we're going to talk about this probably on Wednesday when I hand back your test, but no, I think I'll talk about it actually this Wednesday. That actually kind of between the galaxies is a bunch of dark matter, kind of holding them together. So our vicinity is called, our group, our small cluster, is called the local group. Now this is a different cluster of galaxies called the Fornax cluster of galaxies. So again, 100,000 light years. Check this out, 60 million light years. So you're looking at over here. This is, I don't know how to draw. These are my little galaxies. Okay, this is a distant cluster that is called the Fornax cluster, and it is 60 million light years away. That's a lot. So the way you look at this is these dots, they're different colors representing the different types of galaxies. We have spiral galaxies, of course, the Milky Way and the Andromeda spiral galaxies. Elliptical galaxies kind of look like footballs. Regular galaxies, something kind of in between. So this is kind of, and here we have the circle represents 950,000 light years. 100,000 light years, 950,000 light years. I'll buy that. It's kind of a these represent different galaxies with us in the middle. If we kind of break it out and actually look at our entire group, this is all the local group, that's our cluster of galaxies. You're widening it out now to 5.5 million light years. So clusters of galaxies. You can have poor clusters and rich clusters, depending upon if you have lots of galaxies or not very many galaxies. You can have them nice and kind of distributed where they're concentrated in the middle. Those are regular galaxy clusters. Otherwise, if they're kind of weird looking, they're irregular clusters. So this is another, again, cluster of galaxies called the Coma cluster. So again, these are not stars, these are galaxies. This is the Hercules cluster of galaxies. And it's so cool. So this one's regular, where they kind of have, they're dense in the center, and this is irregular. All right, so then the spiral galaxies are usually in the smaller groups, while elliptical galaxies we're going to see make some really large clusters. This is a relatively small cluster of galaxies. To me, I can kind of see some of the spiralness here. And these are a bunch of elliptical galaxies. And I'm going to see if my pen works. I don't know if you can see it very well. See if it'll, yeah. It won't let me write though if I do that. But there's kind of some, there's like some blue streaks right here, kind of right here. And that actually is the guts. It's not guts because nothing was blown up. But those little blue streaks are actually light from a galaxy that's beyond that group. It's called gravitational lensing. We have some gravitational lensing in this image too, those blue streaks. Again, the reason we can see those blue streaks are from a galaxy that's beyond that galaxy. So how far away is this? Well, this cluster of galaxies, you're talking 2 billion light years away. So in astronomy, to me, it's important to get your billions and millions straight. So of course, million is smaller. A billion is a 10 to the third more than a million. So, this is another cluster of galaxies, and we're going to actually talk in the next section about interacting galaxies. These are actually called the eyes. These are not things that I would see on a regular basis with my telescope.
We just called them.
They're called the eyes.
Where are they by?
they're in a far, far away in a cluster of galaxies. I don't know. Now it doesn't say how. Well, it doesn't say how far away. You're talking about this whole set of galaxies is about 15 million light years from us. Closer than the 2 billion, but still quite a ways away. And this is looking at a cluster in different wavelengths. This is using the Spitzer Space Telescope. I like visible light. This is infrared. But. So I mentioned on here that the galaxy clusters actually are grouped together. So this is the local group. That's the galaxy cluster, and the clusters are grouped together in superclusters. Okay, and that's what I'm going to talk about next. Notice this says that actually the clusters of galaxies are not gravitationally associated with each other. So I'm going to play this video, this short video, and it's going to start to set the stage for, if we go into outer space, what does outer space look like with regard to where the stuff is? And where the stuff is the stuff is in galaxies, and the galaxies are grouped, and then the groups are grouped into superclusters. And they are all around these large void areas, kind of like the little pockets of air in a sponge. So, I can't remember if this had any sound with it. A cool purple color, but this is actually kind of the structure of our universe in our vicinity. And kind of these black dots represent galaxies. So you can kind of see the sponginess, that's kind of how it's described. Of course, there is an edge to our observable universe. We'll be talking more about that when we talk about the Big Bang, Unit 5. But there actually is, this is a sketch, and that's a figure. Let's see, I have one more video to show you, I think, this topic. So, again, local group, okay? So that's like just the cluster. It's called the local group. And then, of course, our local group cluster is in a supercluster called the local supercluster. You're like, really? So let's take a look at this video. This is kind of a short section, but I think it's a pretty section. This is actually the same pair of galaxies that are doing what the Milky Way and Andromeda are eventually going to do. Now, if, such as the Milky Way and Andromeda, if we're similar sizes, we actually call that a merger, okay? If one's bigger than the other, we call that cannibalism. So this would be a merger of what's happening right now. It's kind of cool. I like this little kind of tail thing. It looks almost like a heart. All right. So again, this is just kind of showing you galaxies interacting. They have neat names, like this one's, the D is the tadpole galaxy. It's like a tadpole. E is the mice. F is, let's see what it is. This is a computer simulation of what happens when galaxies merge. I like the video we watched because it kind of said that after our two galaxies, the Milky Way and Andromeda, merge, they're going to just make a big, humongous elliptical galaxy. And as you might imagine, sometimes people will ask, and I've heard it answered, that the supermassive black holes in the center of the Milky Way galaxy and the Andromeda galaxy will merge and make one humongous black hole. I mentioned that if they're not similar in size, if one's a fair bit bigger, then we're going to call that cannibalism. I just think that's so funny. So this is an example of galactic cannibalism. This is kind of an irregular sort of galaxy that exists today, and we know that a big one swallowed a little one by kind of looking at the heart and seeing it's got two hearts. This is showing you galaxies interacting and colliding. Oftentimes, the word starburst here, oftentimes as they collide, that actually, the collision gives little, we talked about, because in order for stars to be born, they're born in these molecular clouds. It kind of gives the little bit of a push to get the, like if you're building a snowball, it gives the little bit of a seed that you start out with a snowball to form. So these look farther away, and actually we'll be talking about that, I think, after your test, something called redshift. And so really distant galaxies have this red appearance to them just by nature. And this is showing you some very distant galaxies, 8 billion light years away, interacting. Another galaxy interacting. Distant merging galaxies. And one of the things about looking at things far away, they have a red color. And the other thing is looking at objects far away, the telescope, it looks kind of fuzzy around, which kind of makes sense because it's so far away. But also the galaxies look to be kind of misshapen, because we're looking back in time, a time when they didn't have time to go ahead and kind of take the edges off of their what they look like. Yay! Well, that's as far as I wanted to get. And then I guess we'll see you Wednesday.